Okay, welcome to our Hariharan Express channel. Today we will discuss encoders. The topic is encoder. Before encoder, we have already discussed that is a decoder, how to design decoders in a different ways. That topic we have already discussed in last lectures. Okay, so today we will discuss regarding on encoder. Encoder is the reverse construction of decoder. Okay, whenever decoder will construct, okay, if that construction we understand or how to design decoder, it is very easy to construct encoder. Now you will see we will define these encoders. We have already known that decoder is a combinational circuit. Similarly, encoder also it is a combinational circuits. It is described, encoder is described as a combinational circuits. Okay, that performs, that is a reverse of operation. Reverse operation we can tell as a inverse operation of that is a encoder. It is a inverse operation of encoder, and whenever we design encoder, then we can consider we can consider reverse design a reverse concept of a decoder. Okay, if we go through decoder, for example, if we go through decoder, then what happens? We will consider n inputs. Okay, n inputs. What is the output? 2 to the power n output. Okay, the n inputs we will consider whenever we will take n inputs, then we will get a 2 to the power n output for decoder. If we go through encoder, then what happens? Just it is inverse of that decoder. That means we will consider maximum 2 to the power n inputs. Okay, this is the output, but in case of if we go through encoder, we will consider a maximum 2 to the power n inputs, and we will get that is a n output. Okay, n outputs. Just a reverse or inverse of decoder. Okay, encoder is reverse of decoder. Very simply, it is a, for decoder it is n inputs we will consider, 2 to the power n output we can get. Similarly, if we go through encoder, maximum 2 to the power n inputs we will consider, then we can get n outputs. Okay, this is that is a conversion of information from input to output. This is the basic concept. Similarly, whenever we design the output line, generate binary code of corresponding of the input value. Okay, because output here output n output, but it depend on the 2 to the power n inputs. Okay, for the reason the design also defined accordingly. Like suppose go through decoder, what is the design? We can write or we can tell 2 into 4 decoder, one design. Okay, or 3 into 8 decoder, we can define or we can call as like this. Okay, similarly encoder also name similar kind, I mean just reverse of that. How? Because reverse of that input and output. Similarly, we can tell for encoder in this manner, like that is 2 to the power n into n encoder. Okay, n encoder. So if we consider n is 2, for example, n is 2, then 2 to the power 2 is equal to 4. Okay, that means 4 into 2 encoder, we can tell as a 4 into 2 encoder. This is the one example, best example. The form of this encoder will be like this, format of this. Similarly, we can write 8 into 3 encoder. Okay, 8 into 3 encoder. So different name also we can create and we can name or we can call this kind of a encoder. Okay, so whenever we will consider this encoder, okay, normally very simple way we will consider the inverse of a decoder. What are the decoder? We will consider the inverse of a decoder. Okay, now we will construct how this encoder will construct. Okay, very simple way, that is a combinational circuit we will consider for encoder. Very simple way we will consider how, like we see very simple way here, very simple way to design this that is encoder. Here if we go through this one combinational circuit for encoder, what that is a design name we can tell as a, that is a 4 into 2 encoder. We can tell as a 4 into 2 encoder. That means 4 input will provide to this encoder. So what are the 4 inputs? Very simple way, if we go through 4 inputs, we will provide in this way, like A0, A1, A2, A3. These 4 input will provide to this encoder. Then we can get, that is how many output we can get, that is 2 output, because first 4 consider as a input and second 2 consider as a output. The output is defined in this way, that is D, that is here D1, we can write that is D1, here is D0. Okay, one is D0, another is D1. So 2 output we can find. Okay, based on 4 input we can get 2 output, that is D0 and D1. Okay, this is the design of what we can call, that is design of or construction of, we can tell as design of 4 into 2 decoder. Okay, design of 4 into 2 decoder. The design of 4 into 2 decoder in this manner. Very simple way, we can take 4 input here, A0, A1, A2, A3, 4 input and 2 output D0, D1. Okay, that means whenever provide 4 input, then we can get a 2 D0, D1. Okay, this is the basic concept. But whenever we will go through truth table of this encoder, that means truth table of this 4-2 encoder, then how to design or how to use those inputs, and we will get that 2 outputs. 4 inputs we will provide. Now how to get this 2 output? Okay, that we will see. This is the basic design, that is very simple way we can design. But whenever you go through, that is truth table analysis, then how 4 inputs will provide to the truth table, and how that 4 inputs provide 2 output, that is we will see. Okay, so now we will see very simple way how 4 inputs provide, that is 2 outputs. Okay, now we will see. Now we define, that is a truth table. Now very simple way we define truth table for 4 into 2 encoder. 4 into 2 encoder. Okay, this truth table we have to design. Now we see very simple way. Here how many inputs we will consider? That is 4 inputs. How many output? 2 output we can get it. Okay, now similarly we will take, that is 4 inputs, 4 outputs. Okay, very simple way. Let's see. First one is let A3, here A2, here A1, here A0. Okay, 4 inputs we will consider. Similarly, output will be, that is D1 and D0. Okay, these output. So here what happens, we can consider like here is that is these are inputs. Okay, these are inputs and this is output. Okay, this is output, this is input and this is output. So now see, whenever we will provide input, how to get output. The previous, if we go through, that is a decoder, then we can also define how if we go through decoder, that is a very simply whenever go through decoder. Okay, very simply we can also, I will show you how decoder, very simple way, you see, very simple way we can define here. Okay, for decoder, here what happened, two input A1 and A0 and A1. Then what happens, D0, D1, D2, D3 we will consider. Here is 0, 0, 0, 1, 1, 0, 1, 1. Just a remind point of view, I will show you. Okay, and similarly D0, whenever we will provide A0, A1, 0, 0, then D0 will activate. Whenever provide 0, 1, then D1 activate, because its value is 1, its value is 2, 1, 0 is 2, D2 will be activated. When value is 3, D3 will be activated. Just a reverse case. This part considered as a input, and this part, this two input part considered as a output in encoder. Okay, how it will consider? Same case. Don't worry about this. Similar case. Just we will consider this. These are these are inputs. These are output. Okay, very simple way we will consider. So now you see how it is defined. Okay, you see, whenever go through this one, very simple way. Now I will give some instruction, very easy way we define. Whenever you go through, suppose decoder, it is a 0, 0, these are considered as input, but now we will consider what, that output. Okay, that is, suppose consider reverse case, 0, 0, output is one is 0, another is 0. On what basis this is 0? Whenever A0 is 1, other part will be 0. 0, 0, 0, whenever this A0 is 1, then D0 is 0, D0 is 0, D1 is 0. Okay, similar case. Here is here 0, here is 1, 0, 0. Then what happens? What you will get? It is 1, it is 0. Very simple way. Reverse case, just reverse case we can apply. So input will provide, this is 0, this is 1, 0, 0. Then automatically D0, D1. Okay. Similar case, just you will consider this is the input. Just we can consider it is the output and this is input. So obviously we can easily to remember how this will create. Similarly, here it is 0, here is 1, 0, 0. It is easy to give to the this truth table value, then easy to find out. Here is a 1, 0, it is 1. It is a 2. You can write it 2. Okay. Next, here is also 1, here is 0, 0, 0. Here is what happens? 3 value. Okay. It is 3 value, A3 value, we can write A3 will be activated. So 3 value means it is 3. Okay. Now very simply, A0 value will activate, that means D0. Okay, other 0. A1 activate, value is A1. A1 means it is 1. It is 0. It is 0. 0 means both are 0. Okay. If it is 1, 1 means 0, 1 is 1. A2 is 1. So A2. Okay, 1 means A2 activated. That is, it is 1. It is 2. It is 2. It is A3 will activate it. Its value is 3. So it is 3. So in this way, we have to remember how to design the truth table. Okay, how to design for truth table for 4 into 2 encoder. How to design? This is the very simple way we have to take it. Very simple way. A0, A1, A2, A3. Similarly, D0, D1. So left, that is the right hand side to left hand side, you just write 1, other 0. Next, A1 1, other are 0. Here A2, here 1, others are 0. Here A3 1, others are 0. Similarly, here it is 0, so value will be 0, 0 0. So it is 1, it is 0, it is 1, it is 1, so it is 0 1, it is 2, it is 1 0, it is 2 means here, so 1 0. Here A3 is activated, it is 1 1, because 3, it is 3, 1 1 is 3. So like this we can that is find out or create this truth table for this 4 into 2 encoder. Okay, so this is the basic concept to design for 4 into 2 decoder. Okay, so similarly we can also design that is 8-3 encoder. This is the 4-2 encoder. Similarly we can design that is a 8-3 encoder. Okay, 8-3 encoder we can also design. It is very simple. Similar, if we understand this 4-2 encoder, we can also design and define 8-3 encoder. It is very simple way. Okay, in this case what happens, we can consider that is a 8 number of inputs. Here is what happens, 8 number of inputs and that is a 3 number of outputs. Okay, 3 number of outputs. So how we will design that is a 8-3 encoder, now we will see. Okay, so now we will see how we will design that is a 8-3 encoder. Okay, very simple way I will also show you. Since 8-3 design we will consider, then what happens, we will consider that is a 8 input. Okay, 8 input consider like a D0 to D7 and very simple way, same thing you can consider that is a 8-3. Other name also we can define, suppose 8 into 3 encoder, sorry 8 into 3 encoder. Other name also we can call as octal. 8 for octal to binary encoder. Okay, octal to binary encoder. Other name also we can tell octal to binary encoder. So, but actually binary is 2 digits. We can tell binary 2 digits, but actually name is that is 8 to 3 encoder. This is the under, that is a octal to binary encoder. We can tell as a octal to binary encoder. We can tell in this manner. Okay, so now we see very simple way we define or design this encoder, that is 8 into 3 encoder. How many that is inputs are required? That is 8 input, and 8 input defined through D0 to D7. Okay, D0 to D7. How? Very simple way we mention D0, D1. Okay, and D that is D2, D3, D4, D5, D6, okay, D7. So D0 to D7 we can call this data as inputs data. What? Inputs data. How many inputs? 8 inputs. Okay, these 8 inputs, so we will consider for this encoder. Similarly, whenever we design this encoder, we also call this, what is this name? That is a 8 into 3 encoder. Okay, 8 into 3 encoder or 8-3 encoder we can tell. Short form sometimes some people also we call as a 8-2-3 encoder, 8-3 encoder, like this. Okay, so how or what are the outputs? Okay, since it is a that is a 8 inputs, we can consider as a 3 outputs. Okay, we consider only 3 outputs. The outputs can consider x, y, z. Okay, or a0, a1, a2 we can consider, doesn't matter. Whatever things we can consider, doesn't matter. Now we will see these simple 8 into 3 encoder we design in this way. Okay, so now we will define or design for the truth table. Okay, truth table whenever we consider similar case, that is what 4 to 2 like 4 to 2 4 into 2 encoder, just like a 4 to 2 encoder, the truth table of 4 into 2 encoder we can also design, that is or define or create truth table for 8 into 3 encoder. Similar kind of truth table. Instead of 4 we consider 8 inputs, and instead of 2 output we consider that is a 3 outputs. So 8-3 means 8 input 3 output, 4-2 means 4 inputs 2 outputs. So similar concept also we can define. Okay, now I will also show you how it is defined for this particular output. Okay, now you will see how it is defined. Truth table also we define here, truth table. Okay, truth table. Now see how truth table will be defined. Very simple way I will show you. Also I will show you in this way. Okay, so last one we can tell as a, that is a D7. Okay, so we can also write D7, here is a D6, here also D5, D4, D3, D2, D1, D0. Okay, these are the what inputs. Okay, and output we can get x, y, and z. These are the outputs. Okay, so we can tell these are the inputs, these are the output. We can tell as these are output. Okay, and these are the inputs up to here. These are the inputs. Okay, these are the inputs. So now you see, whenever we enter this data, how it will receive these 8 input and how it will provide, that is a how many 8 input, it will provide 3 output. How it will provide 3 output, we will see now. Very simple way we will see. Now whatever starting from here, similarly very simple way we can write now. Start from D0 is 1. Okay, here is a 0 0 0 0 0 0 0. Okay, in this way we can also define, because starting is 0, D0, D1, D2, D3, D4, D4, D5, D6, D7, that is 1. Similarly, if we go through this one, then output will be, since it is 0, very simple, it is 0, all are 0. So 0, 0, 0. Since it is D0, so this value will be 0 automatically. You see, this value will be 0. So we can write this is 0 value. Next, it is 1 value. If it is 1 value, then what happens? Which will be activate, or which data will be provided, or which inputs will be provided to make a output? This is a D1. D1 provide output. So other part also will be 0, 0, 0, 0, 0, 0, 0. Okay, and in this case, what happens? It is a 0, 0, 1, because it is a 1. So it will total value, this output will be 1, and depend on this D1. Similarly, we can write, suppose it's 2. It is just for understanding I will write here. That is not actually required, but for understanding I will write here. So it is 2. 2 means 2 binary form. Here it will be only binary form. Okay. This binary form also we can see how it will generate. This binary form we see how it is 1, 0. So it will automatically 0, because 2 value binary form of 2 value is 1, 0. This is the output, but this output depend on this 2. 2 means D2. Here is a D2. Okay. Here is 0, 0, 0, 0, 0, 0, 0. Only depend on that. Similarly, also other part we can define. How? Very simple way. Here is 3. 3 means D3. D3 is 1. Other part will be 0. And these 3 means here how to define? 1, 1. It will be 0. So other part also 0, 0, 0, 0, 0. Here will be 4. 4 means here binary form of 4. Here is 1, 0, 0. Okay. So here is 4. D4. 4 means D4. Here is 1. Other part will be 0. Okay. Now it will be 0. All are 0. Okay. Like this we will fill up other. It is 5. 5 means here 1, 0, 1. Okay. 5. 5 means D5. Here is 1. Other part will be 0. Okay. So there is 0, 0. Similarly 6. 6 means what? It is 4, 2, 0. It is 0. So 6 will D6. It is 1. Other part will be 0. Okay. Very simple way we can fill up this truth table, which are 0 or which are 1. Here is a 7. 7 means what? All are 1. Here all are 1. Which one? 7 means D7. D7 is 1. Other part will be 0. Okay. Like this we have to define, or we have to design the truth table where D0 to D7 consider as, that is inputs, where X, Y, Z consider as a output. But these output, whenever we will consider, we can find out the binary value of that output, that is 0, 0, 0, 0, 0, 1, 0, 1, 0, or like this. That is a decimal number we consider. Through this output we can get 0 value, 1, 2, 3, 4, 5, 6, 7. 7 value we can get as a output, but that will be depend on this, that is D0 to D7 inputs. Okay. D0 to D7 inputs, that which inputs value will activate, by which we can consider that value as a output. Okay. That depend on that inputs. So that inputs is very, very important. The D0 to D7 is very, very important, where it will provide the output as output through this X, Y, Z variable. Okay. So this is very, very important whenever we design 8-3 encoder. Okay. Or other name we can tell as a octal to binary encoder. But octal to binary encoder is normally called it, but very simple way we can define. This is a 8 to that is a, or 8-3 encoder. Okay, this is the basic and fundamental concept of encoder. I also designed two encoder. One is a 4 to 2 encoder and 8 to 3 encoder. These two encoder I designed, and I hope all of you understand all these basic concept, how to design encoder and types of encoder and corresponding that truth table of encoder. Okay, so whenever design encoder, that is very simple. Encoder design is very simple, but whenever analyze through truth table, just we will see that how that truth table will consider for any kind of encoder types. Maybe either go through 83 encoder or 42 encoder. We will see that based on that input, how many inputs we will consider and how many output we will consider, that will define or we have to design. Okay, so this is the basic concept I designed for encoder. I hope all of you understand, and I think that is you understand this particular topic, that is encoder and different types of design and its corresponding truth table also. Okay, thank you very much. Thank you very much to see this video. I hope all of you understand, and I thank you to all to see these videos and to watch my channel, to watch my videos, and use or view this channel also, or increasing these views. Okay, thank you to all. Please share it and please comment it. If any comments with you, so please comment to me on these videos, and subscribe my channel and like it if you are interested to see number of times that is in my video. So it is very useful in actually if you are computer science or IT students or IT any faculties or anybody interested to know different subject under IT or computer science engineering subject, so I will provide different topics through my channel. Okay, so thank you very much. Thank you to all. Thank you very much.